Chapter 22 Chemistry Theory Video 2. Now we are going to look at the second way of finding out the order of the reaction. So this is by drawing the graphs of concentration of reactant against time. So to distinguish between zero, first and second reactions, uh, we can use this graph. We will have for the zero order, it would be a constant rate of decline. So that means it is going to be a straight line with a downward slope. Then if you take the first order and second order, however, there would be a curve. So these two curves are going to be quite similar. However, the first order would be a shallow curve. Second order would be a deeper curve. So you might have to go into to figure out the first and second order which is that. Then you might have to go look at some other method as well. So if we after figuring out whether it is a first or second order, if you want to get a confirmation whether it is first or the second order, we have to go and figure out the successive half-lives of the reaction. That will help us to confirm whether it is a first order or a second order reaction. Write down number 2, graphs of concentration of reactant against time. Graphs of concentration of reactant against time. When this graph is plotted, we will get the following details. Please draw this graph. 22.4, time against the concentration of reactant. So you will get first order as a zero order as a constant rate of decline, and first order declines in a shallow curve, second order a deeper curve. Write that as well. Between the first and the second order reactions, we can distinguish by using half-lives of the reaction. Please do question number 5, and after that, after you have completed it, we can go to half-life and reaction rates. So half-life, that is T half, is the time taken for the concentration of a limiting reactant to fall to its half its initial value. This is just like the half-life of nuclear reactions, nuclear materials. So we have discussed about half-life of radioactive materials. This is something similar to that. Half-life is now because we are talking about the concentration, half-life is the time taken for the concentration to halve from its original value. So now here they have given the half-lives measured for cyclopropane to propene reaction that we studied earlier. So then they will give some cyclopropane mole per cubic decimeter 4 to 2, it takes 17 minutes. Then 2 to 1, it is 17.3. Then 1 to 0.5, it is 16.7. So as a result, you will see that it is a constant half-life. If it is more or less a constant half-life, it would be it is very close to one another, 17, 17.3 and 16.7. So that means it has a mean half-life of 17. Therefore, if the half-lives are more or less constant, we know that they are to be a first order reaction. Because the half-life is independent of the original concentration of the reactants. So that means whatever the starting concentration of cyclopropane, the half-life will always be 17 minutes. That means even if you start at 1000 moles per cubic decimeter or 5 moles per cubic decimeter, 1000 to 500 and 5 to 2.5, it will take the same amount of time to halve its concentration. So then if you take 0 first and second order, you will be able to get an understanding like this. As you can see in the 0 order reaction, successive half-lives will decrease with time. First it will have a higher up value, then it is going to be lesser when time goes by. First order reaction, half-life is constant. In second order reaction, successive half-lives will increase with time. For the rest of the others also, it will be, that is fourth order, third order, etc. For those also it is going to increase, but we don't discuss about that. And also remember, here they have given you that for half-life method, you will be only be expected to do calculations for first order reactions. So if you do this question number 6, you will be able to understand what is expected of you. Write down a note. Half-life and reaction rates. Half-life, T half, is the time taken for the concentration of a limiting reactant to fall to its half of its original value. If the half-lives are, if the consecutive or successive half-lives are fairly close to one another or remains constant, it is going to be a first order reaction. If the successive half-lives decrease, it is a zero order reaction, and if the successive half-lives increase, then it is a second order reaction. Please draw these three graphs, so that you would understand it better. And please go to question number 6. If you have any questions, ask me. If you don't have any doubts, please do the question.